All right, so today we're going to be talking about web scraping, where yesterday we had talked about JSON and APIs. And APIs are basically things that companies or people build so that you can get data in a more streamlined manner. Sometimes the information we want exists on a web page and there is no like nice way to get it. Therefore, web scraping. So to understand web scraping, there is a bit of understanding that needs to go behind like how a document object model works. So basically, for y'all who have gotten into the lessons so far, when you're web scraping, and we're actually going to walk through this example, which is also in the lessons. We're going to walk through this example. And when web scraping, we're actually going to web scrape via the HTML of the web page. The DOM is written in HTML. So basically, with anything you want to web scrape, so today we're actually going to walk through scraping all of this information. Anything we want to web scrape, we have to find out where in the HTML this exists. HTML can be a little bit intimidating and overwhelming to read. Definitely took me a while to get used to it. But what you do is you just inspect. I think on Google Chrome it's all inspect. There is a keyboard shortcut that I don't remember off the top of my head, but any browser should have something similar to this. And usually you have a functionality where you can, select a specific thing and it'll bring you directly to where in the HTML these exist. And I'll like walk through specific examples later. But this is basically the DOM, which is written in HTML. All right, so the way that the lessons are set up, let me actually bring it up, talk about that super quick. How the lessons are set up, the first half, as I mentioned, is actually ported from the software engineering program. These are really fun to go through because you actually get to I think color in a rainbow, and I think there's something with cats somewhere. So that can be fun to just play around with, but it is very granular and much more, it's on a much smaller scale. And as data scientists, we very rarely have to write our own HTML code. So it's not so much about learning how to write the HTML code, which is what these are all about, but it's more about how do we get the information that we want out of the HTML code, which is what this bottom half, which is a little bit more relevant to us. All right, so let's walk through the notebook. So here you can see that web pages are represented by objects that comprise their structure and content, and that basically is the DOM. And most things are written in HTML. So in here, this is not super important to remember, like the structure of the DOM and how all of this works together. I think what's more important is to understand how HTML elements are built and the parts of an HTML element. So let's talk about this, and then when we get into actually scraping, I'll describe the parts of an HTML element. So for our purposes, we're actually going to be using the beautiful soup library. There are other libraries that exist out there for scraping. I think one of them is called ScrapePy, like scrape with a Y. I heard that one is newer and sometimes works better, but for the most part, I like Beautiful Soup. I think it works pretty well and pretty consistently. So what Beautiful Soup allows us to do is to navigate through HTML documents. So Beautiful Soup will basically help you look through this and pull out the specific information that we want. And I'll walk through, again, how to do that. So yeah, to start, we are using the Beautiful Soup library. They're on their 4th iteration. So from BS4, import Beautiful Soup. And we're also going to use the requests library. So request is what we used yesterday to get information from the API. Very similarly, they can actually get all of the HTML from a website. So let's import. And as mentioned, we're going to scrape all the information from this website to get a data frame of books, their rating, their title, their price. Are we going to look at whether they're in stock? I don't remember, but we're just going to get a bunch of this information. So very simple to start, to set up. You start by doing a GET request. And what's really good about Beautiful Soup is they actually have an HTML parser. And a parser is basically something that helps you translate what seems to be like basically a bunch of text. This parser that we're putting into here makes it such that Python is able to recognize the parts of an HTML, parts of a DOM. If that makes sense. So without the parser, this might end up looking just like one big string, which is not what we want. The parser just makes it such that our Python can recognize the parts of the HTML. So to do that really quick, we'll just pass in the content of our HTML page with the parser, and we'll actually take a look. So we run that. There's a lot of code coming up, but no worries. But first, let's take a look at soup. Here, as you can see in soup, we have literally the entire page in HTML here. What this has done is basically took all of this that was here from top to bottom and saved it as a variable, soup. So sometimes soup doesn't look as nice, and sometimes it's all like a little bit messy with the formatting. And so what soup has is a prettify attribute that for this one, I don't think it's much different, but actually this needs a, yeah, it's not much different for this example, but for some examples of HTML, if you see that, for example, like sometimes all of these will be smushed together, you might want to use the prettify. But for this, it doesn't really make a difference. All right, so let's get started. When scraping, usually my advice to students is start small, and then websites are pretty consistent for the most part. Once you're able to scrape one thing, you can end up scraping a lot of things. So on a page scale, I would just focus on getting the scrape for one page down, and then we can work on the pagination later. So what we're going to do is we're going to scrape all of this information. And something else to look out for when you're scraping that I don't think is actually stated explicitly anywhere in any lessons, but when you're thinking about scraping, it's very important to make sure that you're scraping groups of things. What I mean by that is, let's say we're scraping all of the titles separately. So we're getting all the titles separately, and we get, I think on this page, we have 20 titles. Let's say after the titles, we're scraping prices. As an example, let's say if a book is not in stock, the price doesn't show up. And the price doesn't show up, Beautiful Soup won't return you an error, but will actually just return you an empty string. Because of that, if we're scraping titles and prices separately, we end up with 20 titles and maybe like 18, 19 prices. And that way it becomes a lot harder to associate, all right, which are the missing ones, which were the titles that didn't have prices, and then there would just be like a length mismatch, and then you might have to like re-scrape all over again. So usually when you're scraping like rows think of scraping as like you're scraping an entire row at a time. That makes it a little bit easier. I'll walk through the process and hopefully that sort of makes sense. So what I mean by you're scraping a row at a time, instead of going straight and like scraping like, all right, this image and then these like stars, these individual things first, I will actually look for something that encompasses all of that. So the way that HTML is structured, there are different layers, and anything within, and you'll sort of see that with this highlighting, all of these small elements will live within, for example, this big block. Actually, let me bring that in again. Will all be within this green block. Does that make sense? And if we actually take a look, if you see like on the right panel, I'll see if I can make that bigger in a bit. But on the right panel, if I was to, actually, let's use this one. Let me move my thing away. So here we have all the things open for Tipping the Velvet, this second book. Sorry, I know it's kind of trippy with everything moving around. So right now I'm highlighting Tipping the Velvet. So Tipping the Velvet, if I click onto this, and let me make this a little bit bigger. I wonder if I can zoom in the text here. Oh, nice. All right. So here was what I was highlighting, this LI class, blah, blah, blah. this contains everything that I need about tipping the velvet. So this li class column, blah, 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 it contains the image container. It contains like the star rating one. It contains like the URL, the title, the product price, pretty much everything that I need. So when scraping, it's actually a good idea to first get this as one chunk and then doing another function to like break that down. Sound good? And we'll walk through the code of this right now. So basically, with this website, we're pretty lucky that each of these books can be found under this same tag. So if we open up this one, and let me know if like anything is hard to see. Let me see if I can like expand this. Yeah, so we can see that this li class is consistent for every book. So if I highlight over the first, second, third one, we actually get the same thing. So that's going to be our first step, just trying to get these bins of information for all the books on this page. So how we do that is, this is the exact same thing that's in our soup. So let me see if I can actually scroll to find it. Let's see. Yeah, this is one of them. I saw Sapiens one was on here. So this li class thing exists in here. So with soup, the two methods that you're going to be using most are find all and find. Find all, as the name suggests, you find all occurrences of a specific thing, and find actually finds you the first one. So for here, because we know we want 20 books, we're going to use find all. And we're going to run find all onto our soup. So here, there are many different ways to set up the find all. I think this one works best for me because I get to tell it to look for a specific tag and then also look for a specific attribute of the tag. And let me talk through that as well. So the first thing after that like open triangle bracket, the first thing that appears here is what kind of tag this HTML element is. And this HTML element is a li tag, which I think stands for list. I'm not 100% sure, but they're all li tags. So when you're looking it up, you look up the li tag. So that's why the first argument here is li. There are different ways to set up this second part, but this one just seems to work best for me. Within each HTML element, there are different attributes. And so for this, an attribute of this li tag is the class attribute that is this column xs6 colon sn small. This is an attribute of the li tag. So I can look up li tags based on this attribute. Tags can have multiple attributes as well. So for example, just really quickly, this form tag. This form tag has a method attribute and a class attribute. So you can look up this form tag. If you want to scrape this information, you can get you can look it up either by the method or by the class. And it would just be in this dictionary over here. Let me make this a bit bigger as well. In this dictionary, instead of like class, you can replace it with method and get or class form horizontal. So that's how you would look things up. Whenever you see an equal sign within an HTML tag, it is an attribute of the HTML element. Does that make sense? Anything to clarify? Okay, so what we're going to do first is we're going to find all, and the find all is going to return us as a list all the things that have this class. So all 20 of these books, hopefully. So let's run this find all statement. Awesome. So here, find all returns a list. Even if there's only one occurrence of it, it will return a list of just like one element. But here, let's just double check. The length of this is, fingers crossed, 20. There you go. So we found 20 mini soups. And each of these soups will contain the information for one book. So to do that, because this output is a list, we can actually look at the first element. And this is one book. And this should be the first one, A Light in the Attic. All of this is a little hard to read, but just to break down, every HTML element lives within these like triangle brackets. So here you can see there's this li tag. Different things can also live within divs. It's kind of gets a little bit confusing here, but whenever you see something with like a / something, it means it's ending a division, but that's less important for us to know. Yeah, what we have here is all the information for one book. And if we take a look at different books, let's look at like index 7, we have here the book Becoming Women, and they all have the same information, it seems like. So cool. Let's just assign this search result of like the find all for the 20 books. Let's just assign that to a variable for now. And just to check, there's 20, and I'm also going to assign 1 to first, because as I mentioned as well, once you get the scrape working for one thing, we can get it working for all. So what I did here is I assigned all 20 of my mini soups to a variable, and this first 20 is basically a list of 20 mini soups, each mini soup containing the information for one book. And then just for my testing purposes, I'm just gonna save the first one to a variable just so I can run my more meticulous scrapes on the HTML for just one book. So first is just the HTML for the first book. And now we're just gonna play around with this to get all of this working for one particular book. And then we can just apply the same methods to all the other 19 books on this page. Questions about the process that we're taking?
Is mini soups a technical term?
No, mini soup is not a technical term. Yeah, soup is a technical term, mini soup is not. I feel like it's just like the easiest way to refer to it. But yeah. Okay, let's take a look here. So what we're trying to find first, I think what we're trying to find is the URLs, the rating, I think we're also looking for the title and the price, and maybe whether it's in stock. Yeah, so that's what we're gonna do. So first, let's work on the URL. Let's try and look for the URL. So URLs are interesting because they're not immediately visible, like they're not immediately visible on the page. Like it doesn't have like the URL printed anywhere. It's usually part of something else. So in this case, the URL is, when you click on the title, the URL is part of that. So if we actually look into that, let's just talk about this specific part. You can see here that this is actually embedded within an H3 tag, and it has a URL. It's in an A tag, and A tags are most commonly URLs. It's within an A tag, and this URL is it's an attribute of the A tag. So you can see the href is actually an attribute of this A tag, and the title, which actually we're going to scrape later, is another attribute of this A tag. So this A tag has 2 elements that we want. It has the URL and the title. One other interesting thing about like how web pages are constructed is you can see here that this is not the full URL. The way that web pages are constructed is you have a base URL, like bookstoscrape.com is the base URL. And because every page on this website starts with that, this doesn't need to have the full name. It just knows to append this to the end of bookstoscrape.com. So this currently doesn't have the full URL. If we need it, we can do something about it, just adding like, just putting 2 strings together to construct the full URL. But all right, let's work on finding this specific thing. So here we have our mini soup. And actually, we're lucky that this is not too long, so we can see that it belongs here in this A tag here. So, all right, this is first. What we would do here, because we only need one thing, is let's first find the A href. So there's a lot of code here, so let me just like take that away so that's not as distracting. So with a find, actually, let me do this first. With a find, you can actually start with just finding the A. Yeah, let's start with just finding the A. So when we find the A tag, it returns you everything that is within this A tag. This is actually enough, I think. With this A tag, when I mentioned attributes kind of work very similar to dictionaries, which is interesting. So for example, if I know that I want to find this href, you can actually pull out the specific thing just by square bracket href. And that's how we get the URL. Does that make sense? One thing to note, a common error that students do run into is sometimes, just remember, you can't run a .find on a list of items. I'll sort of demonstrate that later, but you can only run find on something that's already HTML. So you can only run .find on things that are already made to HTML. I won't be able to run this .find on like first 20, for example, because first 20 is a list and the .find only works on HTML. So that's a common thing that people actually run into. So all right, we found our href. Cool. So next thing we want to find is the title. Any questions about this thing first before we move on? All right, I will say scraping is a lot of trial and error. I only have this code here because I actually played around with it a bunch, but scraping is a lot of trial and error. There's a lot of times that, you don't start your scope wide enough and then you end up having to rescrape some things, or you're not sure where the information actually lives, so you're basically trying a bunch of different things. That's very, very normal for scraping. All right, so next thing we want to find is the title. And as we saw, the title is actually in the same place as our A tag. Yeah. However, let's like inspect it again. So we can see here that it looks like it's part of our A tag. So let's do this same find function without this href part to try and find that. So here we can see that, all right, it actually exists here in the image alt, but it doesn't have the exact title because it doesn't have, here we saw that, all right, we sort of expected to see this like title part where you have like a light in the attic, but didn't appear. That sometimes happens. Sometimes I think it has to do with if you have like flash elements on your page or specific, what's it called? Like, not HTML elements, but if you have like, yeah, basically think of it as a flash elements, it can actually change your HTML. So that's why sometimes it looks different when you bring it into your soup versus what it looks like here. Kind of annoying, but that's how it is. So all right, so if that didn't appear in our A tag, that's actually what I like to do is either, actually, yeah, what I like to do is I like to go wider. I like to widen the search a little bit to see if it still appears there. And in this case, the tag that's right above this is the H3 tag. So the H3 tag, you can see, also sort of encompasses the title. So actually, let's look into H3 and see what that gives us. So let's do first.find H3. Oh, nice. So within our H3, we see that we have our href, which is, what we expected because A is within H3. But here, finally, the title shows up again. So what we can do here is within H3, you think what we can do is find title. However, we ran into a key error. Kind of annoying, but anyone want to guess why we ran into a key error with title? Let's put this back here. This is what we had before. We saw that title was here, but when I did the similar thing that we did with href for here, the title didn't come up. Any guesses as to why?
Because they are not separated?
Because they're not separated. That's a good guess, actually. Yeah, it doesn't look like they're separated, but for HTML, if you actually have a space within a tag, it is actually separated. Yeah, they don't use commas or anything, but with HTML, a space counts as separation. All right, it's kind of tricky to, this is actually kind of tricky to figure out, but basically, title is not an attribute of H3. It will take a bit of getting used to, and this is really something that I personally only figured out through trial and error, but this title is an attribute of the A tag, which, I mean, kind of weird, right? Because when we did the find on A, the title didn't show up, but it's technically a part of the A tag. So to do that, we can actually do a dot find again. So we can sort of narrow down from this H3 to the A. So we can actually do another dot find because this is still HTML. We can look for the A. And now you see, I mean, it's kind of annoying that we had to do it 2 ways, but I mean, it only works this way, but not this way. Now you can see we can pull out the title by doing title. And we get that there.
Excuse me.
Mm-hmm.
Find method is only working on HTML elements.
Yes, the find method only works on HTML elements.
So we can put H3A.
Can't do like, oh, you mean like H3 and then like A?
Yes.
Let me actually see this. I'm not 100% sure. I know there are many different ways to do it. Let me see. Yeah, so this actually returns nothing. And find doesn't return you an error if it doesn't find anything. So I don't think this syntax works. I'm trying to think like if I were doing this, let me see, maybe this might work. I'm not sure if this will work, but let me try. Actually, no, I don't think this will work because this is part of the A tag, but I don't think this is a good example to check it out. We'll do another one. We'll do another one.
Thank you.
Yeah, I think the ones later on will have, I think, what you're talking about. But all right, what we got back to was we did the find H3 and then the find A.
I've got a question on, like, when we're doing find, we're doing it on, you mentioned tags several times. Then you just said element. Are tags and element the same thing?
So
can you look at the HTML and show us what things are tags?
Yes, that's a really, really good clarification. This entire thing is an element. The very first word or like letter or like couple letters after the open triangle bracket is the tag. Does that clarify? Yeah.
Can you pull up the HTML and show us like a couple of examples in there?
Yeah. So here, this is the same one we're looking at. This entire thing is an element, and A is the tag. Here, this div is the tag, and this entire thing is an element. And elements can be within elements as well. So for example, you can sort of see here that there's like a closed article. So that means there has to be an open article somewhere. Here, an article. This entire article is an element, and the tag is article. So the tag specifically is the first thing that appears right after the open triangle bracket.
So find will only work on the tags. Like we couldn't put in find href. Right? By itself.
To be honest, it's not something I've tried. I'm not sure if that works or not. Let me do that really quickly. So let's do first.find href. Yeah, I don't think it works because first actually does contain the href. So I don't think it looks up via, and href is actually an attribute of the element.
Okay.
So yeah, you do have to look it up by tag. Thanks for clarifying.
Thank you.
Yeah, thank you for clarifying. So cool. The thing I wanted to talk about is you can sort of see here in this A tag, yes, we got the title from here, but there's also something here that is actually between the open A tag and the close A tag. In this situation, seems like it's better to get this because this looks incomplete. But in this situation, there will be situations that come up that you want to get whatever information is between the open and close tags. And just for y'all to know, to get that out, I think you can do .text to get that, or I think .content may or may not work. Okay, never mind, not .content, but .text to get what's between the open and close tag. Because so far, we've only been pulling things that are part of the attributes of the element. So here we got our title because the full title exists here. So here our title goes here. We have our title. Questions so far?
Just a quick question on the stacking of the dot finds. Is that the same result if you use next sibling?
Oh, that's a good one. With next sibling, is not something that I typically use, so I'm not 100% sure. So let me try. First I'll find H3, and I think the syntax is it next underscore sibling?
I think it's capital S.
Okay, like that, right? So that doesn't look the same. It is returning something. I'm not sure where that \n comes from. Let me just look at this really quick. Not too sure where \n is coming from, to be honest. But based on that, not exactly the same. Next sibling is an alternative to, it's not the same as doing .find on each other, but I think it's an alternative to find like adjacent elements. But anything you can do with a next sibling, you can do by using .finds on other things. For me at least, it's a lot more straightforward to just use the .finds. I've never been in a situation where I haven't been able to find a specific thing. But yeah, that's a good thing to bring up. I, to be honest, don't use that very often. I don't think many people do, but I guess good to know as well. Okay, all right. So what we've done is we found the URL that this links to, as well as the full title. So next, let's actually take a look at the price. Yeah, I think what we're finding next is the price. And let's actually just move this up since this exists already. The price exists here. So if I were to select, it belongs here in price color. Pretty straightforward. This one is a pretty straightforward one. You can see it's in a P, as a P tag, and has a class of price color. So very straightforward. We can do a .find in this syntax, finding the P price color, and that brings you this entire thing. And yeah, similar to what I mentioned earlier, you can just pull out the number by doing .text. And I think, I'm not sure, Ali, if this was your question earlier, but with .find, this is how you would also search out with an element, with an attribute if it's associated with the tag. Cool.
Yes, thank you. Yeah.
You're welcome. All right. Finally, we want to see if it's in stock or not. So with the in-stock availability, if we were just to hover over an element, the in-stock element, it is nicely named in-stock availability. And then it has a string within it. So for that, what we're going to do, let's take a look at in-stock availability first. And it contains whether it's in stock or not. And here we can actually take a look at the .text, because it is actually, there is this I thing here, but the in-stock words are actually between the P tags. So if we take a look at .text, it brings us this in-stock thing, which is, I mean, not super clean with all these like /n things, but we can clean that up later. Finally, the last thing we're going to look up, the last thing we're going to look up is the star rating. Don't worry too much about this stuff, but what we're going to look at is star rating. I'll explain briefly what that's saying later. But with the star rating, you can sort of see that you have like these star icons. And each of them is its own element, kind of. You can see that. Let me click onto one of these. Yeah, so each of these, within the star rating, there is an icon star. And there's actually 5 for each. And there's a difference between, it's not a clear difference between like the yellow stars and the unfilled in stars. So we're gonna have to find a different way to do it. Also, if you notice, like for this, for the thing that contains these stars, it actually says what star rating it is. So it says star rating 3. For this one here, it actually says star rating 1. So that actually can be kind of helpful, but a little bit tricky for us to figure out what to scrape, right? So what we did here is instead, we're actually coming up with a search term. This is Regex, and Regex is actually a really, really powerful tool that we're going to use in phase 4 for searching up specific elements of text. So it actually allows you to give different conditions for searching up text. In this case, what we're doing is we're going to search up any text that has the word star rating, and these are wildcard characters. Regex looks like gibberish, especially with these characters here, but all this is doing is it's giving it a condition to look up any class that has the word star rating in the string of the class. Does that need any clarification? We will talk about Regex when we get to natural language processing in phase 4. But cool. With that, we know that this, this variable Regex actually contains this condition. So this dot find is going to find any class that has like star rating whatever. So it actually doesn't matter whether it's star rating 1, 2, 3, 4, or 5. It will look it up. So if we were to run this, you can see that it gives us our star rating 3 plus all the icons and yada, yada, yada. From this, what we want is this, right? So from this, we have our dot find with our p tag here. We can just from that pull out this word here, and then we can clean that up later because this is the one that actually has our information of how many stars this book is rated. So similar to what we were doing before, this is an attribute, so we can pull it out like a dictionary that this is star rating 3. And surprisingly, in a great way, this returns as a list. And so we can either index 1 or, to be a little safer, just in case there are more things. I mean, it does depend on the web page. I think I ended up doing -1 just to get the rating of 3. So we've actually already scraped all the information that we want off of one book. And the next step is just going to be putting that all together into a function to be able to scrape all the books. But any questions on anything so far? I know that this is very, very different from what we've been doing. It's a different way of reading literally another language of code. So it does take a lot of practice. There are a few websites that are good to scrape. So for some of the upcoming morning warm-ups, I'll actually be giving out like scraping exercises.
I just have one question.
Yeah.
So could we use the dot text on the class rating or the star rating?
Yeah, so anything that you want to pick out with dot text is if there's any text that is between tags. And it's kind of hard to explain, but you see for this P element, there's an open and there's a close. Mm-hmm. And the openings and the closings both have their own sets of triangle brackets. You would use dot text on anything that's between that. So as an example, let's actually look at let's look at this one. So with the price, we use the dot text because the price that we wanted to get was between the open and the close of the P. And so dot text will pull out what's between that.
I see.
Mm-hmm. So for this, if we did, let's see. So if we were to do a dot text on this, so which means instead of this, we do a dot text, it's not going to return, well, actually it does return something, but not the information that we want.
Okay.
Yeah, but that's a good clarifying question. What was I doing here? I was doing class.
The code that we are inspecting does include HTML and CSS.
This that we're inspecting is only HTML. So the way I understand HTML and CSS is that you can write HTML and then you can actually have CSS elements within these. So the CSS is basically these classes. So like different, for example, like design attributes are defined in the CSS file. And so like, for example, in the CSS file, they define this thing for like, all right, so maybe for like icon star. So for in the CSS file, they actually define like icon star is going to look like this. And then that's how the CSS is used. But this itself is HTML. Does that make sense?
Yes.
Yeah, I know it's kind of hard to grasp. So basically all of these class names, to my understanding, if anyone else knows, please butt in. But to my understanding, the CSS is a separate file that actually defines how all of these will appear. So therefore, like if I were to change like the class to something else, the formatting might change.
And why is web scraping considered as a denial of service attack?
Why it's considered a what?
Denial of service. I read in the.
Yeah, yeah, that does come. It does bring into question, like, you know, the ethics of web scraping and like, all right, if they're not gonna give me their data in a nice API, I'm gonna scrape it. It's kind of like stealing. So yes, because of that, it is kind of, yeah, not, you shouldn't scrape things that, you know, are like, I don't know, a good thing to keep in mind. Like, all right, if someone's making you pay for your data, you shouldn't scrape it. So yeah, definitely keep that in mind. There are some websites that actually block scraping. So for example, I know that like one time I was trying to scrape Reddit and Reddit actually blocks scraping. They actually sent me like a message through my beautiful soup. So my beautiful soup actually had output like something like, we see you're trying to scrape this, don't take our information. I forget what it was, but some websites have that in place. And yeah, sometimes there are like fun Easter eggs within those. So there are websites that are like known that are okay to scrape. Like these are literally toscrape.com. I think Craigslist is a scrapable website. Wikipedia is a scrapable website as well. But yeah, if you see any like big copyright signs or any paywalls, ethically you shouldn't scrape.
Okay, thank you.
Yeah, that's a good thing to bring up for sure. All right, let's tie everything together. Here what I have is I defined a function that literally was doing everything I did before. So what I am doing here is I'm actually constructing a dictionary, and each of my keys of this dictionary is going to be an element that I'm scraping. So here you can see I'm doing like title, price, in stock, stars, and URL. And I'm just literally taking all of these, copy and pasting into here. And instead of using first, I just changed all the firsts to book, because this function I wrote is going to work on a single book, which is great because from scraping the first page, I have 20 mini soups that I can put into here. So little things that I did that are kind of different. Here you can see what I did with the in stock. If we remember, the in stock looked like this, which is not great. So all I did was to check for if this string is within this string. So I think that's the only thing that I did that was different. Okay, cool. So find this function, and you can do this any other way, but what I did here was I did a list comprehension for each book in my first 20, and if you remember, first 20 is a list of mini soups. For book in first 20, I'm just gonna run this clean scrape function here. And once I do that, we can see that each of our books is now in a neat, nice dictionary with all the information that I'd asked for. Finally, what we can do is turn into a data frame. There we go. And so now we have a really nice data frame with all these titles, prices, all of this information. And because we scraped it ourselves, if the data is inconsistent or not clean, it is the fault of the website or our own fault for not scraping properly. But yeah, so this is one entire page of books. Second step of putting it together is pagination. So we likely are not going to just work with one page of results. Very likely we're doing an analysis. We want to do that on many more. So here we're going to paginate. With pagination, because the input, if we remember going all the way back up here, our input to get our very first soup was the URL of the page. So let's just think about, all right, how am I going to get the next page? And so every website's a little bit different, but here you can see that there's a next page button. So with this next page button, let's click that and see what happens. Here, I don't know if y'all can see this, but basically at the end of the URL, they basically have added like a page 2 to the end of the URL. And just to check for consistency, clicking through the next few pages, all that changes is the page number up here. And just to final check, let's see what happens when we put back in page 1. So putting back page 1, it actually returns us, the base page, same information. So great, we can actually just change the URL that we're scraping to get the rest of the books. Does that make sense? Sometimes the URL doesn't change in a nice way. With that, what you can do is actually scrape the next button. And with the next button, you can actually find the URL for the next page. So that might be something that you might have to do if the URLs are not consistent. But in this case, pretty lucky it's consistent. All we have to do is change the URL. So let me scroll all the way back down to pagination. So with our URLs, this is going to be our first, this is one URL. And what I'm going to do here is I'm going to scrape 50 pages of books. 50 pages of books. What I'm going to do first is construct a list of the 50 URLs. So really quickly, what I did here is I did a string formatting, just changing the number from 1 to 50. Now I have a list of URLs, and now I can get my 20 books. Here I'm using a function within a function, but I'm just putting everything that I already did together. So for each URL, I'm actually going to loop through this. For each URL, I'm going to make a request on the page, parse through the soup, get the 20 mini soups. So if we remember, this find all gets us the mini soups. I called this the raw information. And then I do the same list comprehension that I did at the start. Anything to clarify? And then here, I'm actually just leaving it as a list of dictionaries for now, and I'll turn it all into a data frame once I put it together. So let's just define this really quickly. Once I have this, and this function literally just gets me the cleaned versions of 20 books, what I'm doing here is I'm going to do that for every single URL. And what I'm doing here is I'm just extending this empty list with 20 dictionaries each time. Gonna run this. Might take a little while because it's literally pinging 50 pages of information, parsing through all of that, pulling out the specific bits and pieces that we need. And here you can see, just like that, I have 100 books. And they're all in a nice dictionary format. So really quickly, let's just turn that into a data frame and look at what that looks like. And there we have it. We have scraped 1,000 books in about an hour. Let's see, one more thing I wanted to mention, actually a few more things. One, scraping is not always legal, so just watch out for that. Two, a lot of websites, they let you scrape, but they have rate limits. So I think some of you might have faced that with your API. And also I think there might be an issue because you're all working off of Illumidas. They might have they all come off like a similar server, so you might have issues there, but I'm not too sure. But because there are rate limits, some of you might have come across like a time.sleep. Time.sleep, I think it was in one of the API labs, where basically because of rate limits, you want to make your function wait a little bit. So I'm not going to do that now because it's going to take forever. But usually what you would do is maybe between each .get request, between each GET request, maybe I want to do like a time.sleep, and how you do it, you have to import the module time, and I maybe make it sleep like 1 second, just so it like spreads out the number of times that you're pinging the website.
And is that 1 second enough to kind of cover your tracks? So
it depends. It really depends. So different websites have different rate limits. I know like one time one of my students got all of Flatiron School campus banned from the Yelp website. So be careful of that. I believe there's a way, I'm not sure, but there is a way to find out rate limits. For APIs, they definitely will tell you what the rate limit is somewhere on their documentation. For websites, it's kind of, for the most part, trial and error, or it might be something that you might be able to find from the robots. I mean, this one's not something I'm 100% sure about, but I think every, I'll talk about this not right now, but for web scraping, may or may not be able to find the rate limit. Sometimes they print it out for you. So while you're trying to do a GET request, instead of giving you the soup that you're looking for, it might return like another message saying you've exceeded our limit of like 10 pings per minute. That's something to look out for too. Let's see. Yeah. What else do I want to talk about? Rate limits, and oh yeah, this final thing, scraping tables. So this is actually pretty neat. A website that's pretty common for scraping is Wikipedia. This is usually a good first thing to try when you're trying to scrape something with tables. So let's just go to a random page on Wikipedia. Is there the randomize button? Never mind. Let's just go to the page for data science. All right. If you have something in a table format, which I guess in this you don't, I know that like the Game of Thrones one does. So let's say you have something in this table format. The way HTML looks for tables, not great. So it's actually quite hard to scrape things in tables using Beautiful Soup. One thing that you can try is Pandas actually has a built-in read HTML function. And that is really, really helpful because, and it's basically Pandas read HTML. It will automatically parse through your HTML and return you any tables. So what I'm going to do here, all you have to do is copy and paste the URL into pandas.read.html. And you can see it's going to return you a list of data frames of every table that exists on the website. I don't believe that this is part of the curriculum, but it's a really good one to know that exists. This doesn't look very nice because there's multiple tables. If we take a look at the length of this, there are 12 tables on this website. But let's just take a look at the, maybe like the 5th one. So the 5th one, you can start to see all of the awards that they won. And it's already in like a fairly clean format. That's usually quite a bit of cleaning that has to be done with like maybe the way that these like these strings are with like the commas, a little bit of cleaning, but a lot easier than scraping directly through Beautiful Soup. So something to keep in mind if you're scraping a table, Pandas has a built-in method for that. Cool. That's all I wanted to share for today. Any overall questions? Cool, awesome. Later today, I think I have a break from 101s for a little bit. I'm gonna send out the project pairs. They're gonna be randomized within your working groups, but if it's the pair that you worked with for your Yelp API, I'll actually check and change it so that you don't work with the same person twice. Just letting y'all know to look out for that. All the project details are already up at the end of phase 1. I think I'm going to go through it tomorrow during the study group, but also a good idea to just take a read on your own first. But I will walk through how to set up your project on GitHub. I have a document with all of the Git commands that you're going to want to use at different points, so don't worry too much about that as well. Let's see, anything else? Any questions about that? All right. In that case, have a good rest of your day, everybody, and I will see you all tomorrow.
Thank you.
Bye.